How science works, or why does everybody keep telling me to wear a mask? By a middle school science teacher. Scientists are skeptical, meaning they are not easily convinced, they hold doubt, and they require evidence to change their thinking. So if you've been skeptical of whether or not you should listen to people, you're in good company. You're a scientist. When scientists have an idea, like, I think masks might stop the spread of the virus, they actually don't try to prove that hypothesis. Instead, they make a null hypothesis. In this case, masks do not stop or slow virus transmission. In other words, the exact opposite of what they think. But their entire experiment is based on trying to prove that they're wrong, basically. They come up with an experiment where they control everything possible but one variable. So one experiment that's gotten some news lately has been this experiment with hamsters. They took hamsters infected with COVID-19, and then they put healthy hamsters on the other side of a cage. Now the hamsters couldn't get to the other side, but their air could flow through. And in this one, they did not put a mask to go in the air, and in this one they did put a mask to stop the air. And so everything else is controlled except for that one difference, and then they look at what happened. Now you might be wondering who is doing this research. There's been a lot of sayings about state-sponsored things. Well, this particular research was done by the University of Hong Kong, and there are over 10 researchers that are cited as being part of this study. In general, the people doing experiments are universities, research hospitals, private labs, the Center for Disease Control, or the World Health Organization, or I live in Michigan, the Michigan Department of Health, and there are places that give grants for other places to conduct this sort of research. And so once the research is done, it goes to publication. Now what's nice is that research goes to publication whether or not the scientists like how they turned out. As long as it comes up with a clear outcome, it goes to a publication. And in these publications, they have to meet very strict standards. What you did, how it was done, the results, in particular, the data, so the numbers you got. In this case, the number of hamsters that were infected with the mask and without the mask. So we go back to our null hypothesis, which is masks do nothing. They do not stop the spread. So of the hamsters on the healthy side, 66.7% of the hamsters were infected when there was no mask there. But when there was a mask there, only 16.7% of the healthy hamsters were infected. So it's getting hard to believe that our null hypothesis could be true because there was such a difference in infection rates. This brings us to something called the p-value. The p-value is the probability that the null hypothesis is true based on the results you got. In this study, the p-value was 0.01. So there is a 1% chance that the null hypothesis is true. What that means is there is a 99% chance that the null hypothesis is false. So anyway, most rational people would say if there's a 1% chance or a 99% chance, I'm going with the 99% chance. So we have a 99% chance of this one particular study showing that masks do something. Okay? The other thing to know about publication is that they use peer review. Now, your peer is someone who's equivalent to you. So someone who does the same thing you do or has the same level of knowledge. Review means they look it over, and they make sure that there's no identifying information to control for bias. So people don't know, oh, I know that George is a great researcher. I'm sure it's fine. They don't know who did it, so they have to review it. Sometimes they even have to replicate the results of the study in order to make sure it's valid. So we have the hamster study we talked about. I put a yellow circle to represent that study, and then I put an orange circle around it to indicate that it had been peer-reviewed and then published and accepted by a journal. So here's our hamster study, and I wrote a little 10 to remind us that there were over 10 authors. Now there are other studies that have been done, one at the University of Nebraska, one called the Physical Intervention Study. This was a study of patient rooms in Iran. This was a study of using surgical masks versus N95 respirators. And then I put lots of other dots to indicate other studies because I didn't list them all. Now we have all these studies, and then researchers do a meta-analysis. Now meta just means whatever you're talking about. So if you're talking about metacognition, you're talking about cognition about cognition. In this case, a meta-analysis is an analysis of an analysis. And here's the title of one meta-analysis that was done specifically looking at the implications of physical distancing, face masks, and eye protection for transmitting the virus. At this point, we're starting to see patterns emerge in the research. So we have lots of studies that have all been peer-reviewed. We have meta-analyses indicated with the green boxes that are showing people have looked over a bunch of studies. And actually, I should have drawn them overlapping because a lot of times more than one, or a study will be used in more than one meta-analysis. And now we take all of this together, and this is the scientific community. We say that they reach consensus. And consensus means to reach agreement. Now, why would they come to a consensus? Well, consensus means we can say, as a community, we've decided that all of the evidence is showing that masks are effective. We are going to stop putting all of our resources towards figuring out the answer to this question because we know the answer. Why would they do that? Well, one, they want to move on to other aspects of the research. So now maybe they want to talk about which masks are the most effective, or what kinds of other barriers could be effective besides masks. Some people want to move on to other problems. So maybe some of the researchers are going to go work on a vaccine now for COVID-19, or a treatment for COVID-19, or something totally unrelated. Maybe they were studying cancer beforehand, or climate change. And it's also just the best use of resources and time. So in your own life, you probably have a thing that once you've done it enough times to know this is how it works, you stop thinking about, is it going to work? Because you just assume it will. Every time I flip on the light switch, the lights come on. I've reached consensus that flipping the light switch turns on the light. I can move my brain on to other problems. So with all that said, don't wear a mask because I said so. Wear a mask because hundreds of scientists have conducted experiments, hundreds more have reviewed the data, and thousands of experts have reached the consensus that it reduces the spread of COVID-19. Mask up.